Now example 5.3. Given in figure are example of some potential energy functions in one dimension. The total energy of the particle is indicated by a cross on the coordinate axis. In each case, specify the regions, if any, in which the particle cannot be found for the given energy. Also indicate the minimum total energy the particle must have in each case. Think of simple physical context for which these potential energy shapes are relevant. Okay. So here potential energy versus position graphs are given to you, and on graph the value of total energy that is given by cross and the potential energy that is given by V0. Okay. Now see here, we know this thing, total energy that is kinetic energy plus potential energy. Okay. So kinetic energy that is E minus potential energy. Now kinetic energy that is always positive. Okay. So the region given in the graph for which the kinetic energy is positive, in that the probability of the particle is there. If the region in which kinetic energy is negative, then particle can't be exist in that particular region. Now this one is the fundamental thing. Now let's analyze each graph. Now see here, in this particular graph, here the potential energy after x greater than a, that is greater than total energy. It implies that here we can see this thing, the kinetic energy that is negative in this particular region. Okay. So here the particle cannot exist in this particular region where x is greater than a, and here E minimum that is 0. Clear? Next one. So here see, V0 starting from x equal to 0 to onwards, in each region the potential energy that is greater than total energy. So kinetic energy is negative in all the regions. Clear? It implies that the particle cannot be found in any of this particular region, right? And here E minimum that is minus V1. Okay. Then after third one. So see here, in this particular region, E that is less than potential energy, and in this region also it is less than potential energy. So here we can say this thing, x less than a means in this particular region. Okay, and x greater than b means in this region. Okay, kinetic energy will be negative, so particle cannot be found in this particular region, right? And E minimum that should be equal to minus V1. Actually, see here there is a printing mistake in this graph also. On this side, like this, there is minus V1. Keep this thing in your mind. Okay. Then fourth one. Now see here. So in this one also, you can see in this region, okay, and here in this particular region, okay, the potential energy that is greater than total energy, and after this one, okay, the potential energy that decreases than total energy. So from minus b by 2 to minus a by 2, as well as from a by 2 to b by 2, the kinetic energy will be negative. So particle cannot be present in this particular region. And again here E minimum, that should be equal to minus V1. Clear to all of you?